Here, still looking at 2.04, writing linear functions, specifically asking the question, how are linear functions constructed given a graph? So we have this graph here, and we can see that it's a line, so it's a linear function. And the first thing I want to remember here is that we're talking about f of x, so that's function notation, is equal to mx plus b. That is a linear function written in slope-intercept form. Well, it's the general form of the equation. And so the first thing I want to look at here is the m. The m is a point on the graph, or excuse me, it's the slope. The slope is our m, so m is equal to the slope. And the slope is equal to the change in y over the change in x. And we represent that as delta y over delta x, where those are little triangles. It's a Greek letter, delta. And we can also remember that it's y1 minus y2 over x1 minus x2. That's kind of complicated. We aren't going to focus on that so much later, or now. We'll focus on that later. Delta y means the change in y between any 2 points. Delta x means the change in x between any 2 points. The other part of our equation there is going to be our b. And our b value is the y-intercept. And the y-intercept is the point where x is 0, and it's the b value at that x equal to 0. So when I look at this graph, I can see that right here, that is the point 0, 3, and that tells me that the b value is 3. So I can start writing my equation, here as, I'm going to say that I'm going to put this in plus 3 in orange, because if this were a negative, then we would have a subtract here. So that's an important distinction to make. So here our y-intercept is the point 0, 3, so b is equal to 3. Now when we think about the slope, what we need to look at is we need to have 2 points here. And we can choose any 2 points where the graph crosses the, what I would call the hash marks. So hash marks are the grid here where the grid crosses. And so as the line crosses the hash marks here, there's one, there's one. So all these points right here, those are the points where we can really see clearly what the values of the x and the y are. And so I can use any 2 of those, and I'm going to use this point down here so that we can see this, what I'm going to call a slope triangle now. And the slope triangle is a triangle where we have a vertical part and a horizontal part, and the delta y, change in y, is the measure of that, and the delta x, the change in x, is the measure of that. So here I'm going to write delta y is equal to, and we usually go from left to right. So going from this point down to that point, we're going down, and that means that our delta y is going to be negative. And we're going down 1, 2, 3, 4 units. So our delta y is negative 4. And our delta x here, we usually measure that in positive units, going to the right. So delta x equals 2. So if we look at our slope, so our slope was delta y over delta x, negative 4 over 2. And that equals negative 2 over 1 if we write the fraction in simplest form, or lowest terms, and which equals negative 2. And so what that says, in this form, we can see that it says when we go down 2, we go to the right 1. We go down 2, we go to the right 1, and there's another point. Down 2 and to the right 1, and there's another point. And that pattern continues. It turns out, though, that we could also, because negative 2 over 1 is equal to 2 over negative 1, this says to go up 2 and to the left 1. Up 2 and to the left 1. We can even start right down here. Up 2 and to the left 1. Up 2 and to the left 1. Up 2 and to the left 1. And so noticing that those fractions being equivalent is important, and we can also just write our slope as negative 2. So our equation here then is going to be f of x is equal to negative 2, I'll write that in blue, that's my slope, x plus 3. And so we can see in our graph, we can see the y-intercept at 0, 3. That tells us the b value here, plus 3. We can see the slope down 4 to the right 2, which is the same as negative 2. Now, when it comes to horizontal lines, it's a little different because notice that on this line, there's something that is the same for every point on that line. And here is what it is. This point right here, well, that is the point negative 3, negative 4. And I'm not going to be able to put too many in here, but I'm going to add one more. This point right here, that is the point 4, negative 4. And if you look at those 3 coordinate points, notice that the y value is negative 4 in all of them. So the y value is always negative 4. And that's true for every point on that line. Even here, you know, in where the x value is in between negative 1 and 0. And because the y value is always negative 4, the equation is going to be y equals negative 4. Or if you want to write it in function notation, f of x equals negative 4. Because remember, the y value is always our f of x. Okay? So when we have a horizontal line that's this way, all the points will have the same y value, and so the equation is going to be y equals a number, or f of x is equal to a number. When we're talking about vertical lines, those are lines that go up and down. It's similar because we can see that all of our points, here I'll put one here, and that one is going to be the point 3, 2. And if I put another point down here, that is going to be the point 3, negative 2. And notice that in all those, the x value is 3. So because all of the x values are the same for a for a vertical line, all of the x values are the same, so the equation is going to be x equals, in this case, 2, because all of the x values are 2. 3. Wow, 3. Now, I can't write the equation for this line in function notation because it's not a function. So we don't write non-functions in function notation, so vertical lines cannot be written in function notation. And that is an explanation for how we write the equation for a line given a graph.